Bismillah ar-Rahman ar-Rahim. This is OCW12 again. So we'll try to do this problem one more time. We have the force. This is the force that's given here. 300I minus 260J plus 640K, and the units are Newton. A is 1 meter. So this is 2 meter. This is 1 meter. And this is 1 meter. And this is 9 meter because it's 4.5. Oh no, sorry. This is 4.5 meter, and this is 9 meter, 2B. What is required? They want to find the angle between these two cables. We could notice in this cable AC and cable AB, they have an angle between them. They want to find the angle between cable AC and cable AB. Cable AC and cable AB. So what is the angle between them? Now, we don't have the force of cable AC and cable AB, but we could use the unit vector of the cable AC and cable AB and replace it with the force. It could be like that. Yani, you could do it like this, because the angle between those between any two cables is cosine inverse the force vector AB dot the force vector AC divided by the magnitude AB times the magnitude AC. Okay, so this is cosine inverse of these two vectors dot each other divided by the magnitude of AB and of AC. If you want to put the unit vector instead of the force, it will be like this: theta cosine inverse unit vector AB dot unit vector AC, and that's it. Because it's going to be divided by 1, because the unit vector, if you want to do the magnitude, it's going to be 1. Okay. Now, let's do coordinate A. Because it's going to go from A to C and A to B. So what is the coordinate A? The coordinate A, it's only in the x-axis. So it's 9, 0, 0 meter. The coordinate B, it is, this is minus 1. You can see that this is the positive y, so it is minus 1 in the y. There is nothing in the x because it is in the yz plane. You can see that the B, this is the y, negative y, and this is the positive z. So the point B is in the yz plane. So minus 1 in the y, and the height is 2 meter in the z. That is meter. That's A. B. How about C? C. Now you can see the point C, it is in the y and the z plane, which means that there is nothing in the x. So 0. The y is, you could look at it from this side, it's 1 meter. It's a positive y. And you could look at the z from this side, and that is 4.5. And that is meter. So once we find the coordinate, everything will be in good shape. We could just find out the rest of the problem from the unit vector right away. Now, let's find out, first of all, unit vector AB. Okay, so let's find out the position vector AB first, which means it's AB, so it's B minus A, 0 minus 9 minus 9, I, minus 1 minus 0 minus 1, J, and 2 minus 0 plus 2K. minus 9 plus b minus a, okay, minus 9 minus j plus 2k, and that is in meter. If you want to find out the magnitude of this position vector, it is 9 square plus 1 square plus 2 square, 81, 82. So square root of 85, that will give you 9.27 meter. And then you can find out the unit vector AB, minus 9 over 9.27 minus j, this is I, minus j over 9.27 plus 2k over 9.27 minus 9i over 9.27 plus j over 9, or minus j over 9.27 plus 2k over 9.27. There is no unit for the unit vector. So we found this one. Now let's find the unit vector AC. So the position vector AC, C minus A, 0 minus 9 minus 9i, 1 minus 0 plus j, 4.5 minus plus 4.5k. So this is the position vector, the magnitude. That's 10.1. So the position vector now and the magnitude, you can find out the unit vector AC, minus 9 over 10.1 I plus j over 10.1 plus 4.5k over 10.1. So we have this now for the unit vector. So we found both unit vector. We could find out the angle right away. The angle, it is cosine inverse. You make the dot product between the first one, minus 9 over 9.27i minus j over 9.27 plus 2k over 9.27 dot. So minus 9i over 9.27 minus j over 9.27 plus 2k over 9.27 dot, minus 9, the other one, over 10.1 I plus j over 10.1 plus 4.5k over 10.1. Okay, so this is the two vectors dot each other. So let's do it using the calculator. So okay. So minus 9 times minus 9. So 9 times 9, that's 81. So theta it's 81 over 9.27 over 10.1. This is 0.86. and then minus minus. So this is going to be the second one, minus 9.27 divided by 10.1. 0.0107, and then the other one 2 over 9.27 times 4.5 over 10.1, and that is plus 0.0961. Close this, and then 0.096 minus 0.0107 plus 0.865, and now this is going to be theta cosine inverse 0.95. So what is cosine inverse of this? That will give you the angle 18.1 degrees. So you put here 18.1 degrees. Hopefully that's going to be the answer for the first one. Now let's go for the next one. Now we found the angle. The next one is to find out the force, determine the magnitude of the component of the force, this force, acting along the cable BA. So let's just erase this. Let's erase to see the forces that he's looking at. Okay, now we have a force here, which is given here 300I, 260J plus 640K, and he wants to find the force parallel to the cable BA. So the cable BA. So you need to find out the projection of this force parallel to this cable AB. Okay, but in this time he needs the magnitude. So let's find out what is the force parallel to the cable AB. The equation, if you remember from the notes, it's equal to the force itself in vector format dot the unit vector in which we're going to do the projection at, parallel to it. So that is cable AB, which is the unit vector AB. So you want to find out the projection of that force on the cable AB, you need to use the unit vector, actual unit vector AB. Okay, now what is the force? 300I minus 260J plus 640K. $300I minus 260J plus 640K, and that is dot, what is the unit vector AB? We have it here. So we have this one, it is minus 9 I over 9.27 minus J over 9.27 plus 2K over 9.27. Okay, plus 2K. Okay, so what is the force parallel? Now, we multiply 300 times minus 9. Let's just do it. Calculator. 300 times 9 over 9.27, and that is minus 291.3, and then this one is minus 260, and this is minus 1 over 9.27. Okay, so it's going to be plus, minus times minus is the plus, so 260 and the minus times 1 over 9.27, and that would give you 28.0. So this is 1 over 9.27, and that is times 260. They're both negative. Okay, the last one is a plus. 640 times 2 over 9.27, and that's 138.1. So we add them all together, plus 28 minus 291.3, and you will get the force is parallel. This is in magnitude format, minus 125.22, and the unit is Newton. You just multiply the I times the I, the J times the J, and the K times the K, and then you add them all together. So with respect to that, you could find out the force parallel to the cable AB. Okay. By multiplying this times this, plus this times this, plus this times this, you'll get minus 125.22 Newton. Now, he wanted in Cartesian format. So you could do the same thing, but this time you multiply. This is, remember, this is a magnitude. You could find out the force parallel, but in Cartesian format, in vector format. You just get this F parallel in magnitude times the unit vector. What is the force parallel? It is 125.22 times, what is the unit vector? Unit vector AB, it is minus 9 over minus J plus 2K Okay, so we have now the force in vector format. We put here minus 125, and we put here the force parallel. Okay, so let's find out the force parallel. So let's do the calculator. 9 over 9.27, that is almost minus times minus, which is 125.22, and that will give you 122 I. And then minus times minus 125.22, that's going to be another plus, divided by 9.27, and that's going to give you 13.5 J, and then 2 times 125.22, 125.22, and that is a minus, okay, over 9.27, and that's going to be minus 27K. And that is the force in newtons. So you could put 122, 13.5 minus 27. Now, the last one. The last one is to find the force, the same force, this same force, but this time not parallel, but perpendicular to the cable AB. Okay, so now we will do the same thing, but in this, let's find out only the magnitude. If you look at the equation of the force perpendicular, of course he wanted in magnitude format, so the force perpendicular to the cable AB, it's by doing the equation, which is what is the magnitude, the actual magnitude square minus what is the actual magnitude parallel to that cable square, and you do the square root of that. So the magnitude of that force, we did not find it, so let's find the magnitude here. 300 square plus 260 square. I mean, of course, we don't put the minus because minus square is the plus 640 square. And this $300 square plus 260 square plus 640 square, and that will give you, and the square root, 731. So the answer here is 731, and that answer is in Newton. So we have this one, 731 square minus. What is the force parallel? We have it here, which is 125. Don't worry about the minus. Minus square is a plus, all under the square root. So 731? Yes, I'm mistaken. This is not 731. Let's do it again. 300 square plus 260 square plus 640 square under the square root, that is, oh, the mistake, 753. So this is 753 square. So 753 square plus 125 square, that's under the square root, and that would give you 763 Newton. So you put the force perpendicular in magnitude format, 763 Newton. What will happen if you want to do it in Cartesian format? That's okay. That's okay. If you want to find out the force perpendicular in Cartesian format, you multiply 763, the magnitude, times the unit vector AB. And the unit vector AB, we have it here. So you could convert the magnitude into Cartesian, into IJK. I think this is it for this problem. Thank you.